Hi, I'm Lisa. This is Threshold in China, a segment that gave you a taste of the future before it actually happens. I'm going to talk about emerging technologies that have life-changing potential and assess their ability to influence our life in the near future. The shape-shifting T-1000 robot in the Terminator franchise is probably one of the greatest movie villains of all time. One of the most memorable scenes from the movie is when it morphed its way around prison bars with a pistol in hand. Due to its liquid-solid nature, the robot was almost invincible. Somehow, the robot has become true. Take a look at this. A Lego-like tiny robot is locked in a prison. It finds the right angle and starts to heat itself up and melts into liquid form. After successfully escaping from the prison, it reinvented itself and restored the prototype, just like in the movie. Now let's take a look at this tiny shape-shifting robot to find out what's so special about it. The robot is made out of alloy microparticles, also known as magnetoactive phase transitional matter, MPTM. There are tiny little magnets that can morph its own shape, move quickly. It can also be controlled easily and carry many times its own weight. In its solid state, MPTM has high mechanical strength reaching as much as 1.98 gigapascals. It's like stacking 4 elephants on top of each other on a square inch of an area. The material also allowed the robot to jump up to 203 times its body length, moving up to 1.5 meters per second. Pretty amazing. In its liquid state, it can elongate, split, and merge, exactly like the T-1000. Its shape-shifting ability can be controlled by external stimuli, such as a change in the strength of magnetic field. The change will cause the microparticle to accumulate at one end while stretching out on the other. This allows for shape reconfiguration without any permanent damage or deformation. Because MPTM's composite material has a melting point close to room temperature, when the team uses a different magnetic field, electrons in the liquid metal form current, and these currents flow through the robot's body, heat it up, and eventually melt it. Once transformed into liquid metal, the robot could be stirred through the narrow gaps of its locked cage by more magnets. After natural cooling, the liquefied robot turns back into a solid. Actually, instead of T-1000, the scientists were inspired by nature, sea cucumbers. The slug-like sea creature have the ability to change the texture of their body from stiff to soft and back again. It's like having a piece of rubber that can be made firm or soft depending on circumstances. Sea cucumbers have the special type of protein inside called collagenous microfibrils. When they want to be stiff, the protein packs tightly together and stiffens itself like a piece of rubber that can be squeezed. When the situation requires themselves to be soft, like when they need to escape from a predator, for example, the protein spread apart and the body becomes more fluid-like, so it's harder for the predator to hold on to. And this inspired scientists to explore similar strategy using a variety of materials. Magnetic microparticles aren't the only candidate though. Previous studies by other researchers had tried other materials with varying degrees of success. However, some materials have limited morphological adaptability due to their quasi-solid character. By that, I mean the ability of it to change the shape or form in response to external factors such as pressure or temperature. For example, a liquid can easily change its shape and fit into a container of any size, but whereas a solid is fixed and it cannot be changed that easily. Other materials the scientists tested out were liquid or paste-like, but they lacked the mechanical strength which limited their load capacity, resulting in poor controllability and slowed their speed. So this makes the current research stand out. Magnetic microparticles they choose combine fast locomotion, high mechanical strength, and versatile morphological adaptability to an unprecedented degree. The material can easily switch between rigid and fluid state through the alternating magnetic field combined with ambient cooling. It also opens a world of possibility once unthinkable for traditional materials, for applications such as flexible electronics, robotics, and healthcare. A robot made from the material could be deployed to fix electronics in places that are difficult to reach, for example working as a makeshift screw to fit into holes of whatever size and shape, or being used as a soldering material that can automatically form a circuit and light up a bulb. In one experiment, researchers showcased how a robot could work inside a model of human stomach by removing an unwanted foreign object. Scientists stirred the solid foam robot, measuring about 1 centimeter in width, through the fake organ until it had located the foreign object. It was then melted by a remotely controlled magnetic field, stretched in this new liquid metal state around the object, and once securely hugging it, cooled back into a solid, allowing it to take the foreign object out of the chamber. The vivid demonstration is just one of the many potential applications in healthcare. The robot could turn out to be a powerful tool for many kinds of surgery. The researchers led by Wang Qingyuan of Sun Yat-sen University have already set their next goal, to make a liquid metal robot that can get its energy by devouring aluminium flakes. Basically, it would look like a robotic amoeba and eat like one. The tiny little robot might be underwhelming for their appearance, but just imagine millions of these tiny robot amoeba live inside the body of a giant robot and provide energy to a host by digesting material for it. So how good is it according to the standards of our rating system? Well, let's move on to the threshold rating system: readiness, novelty, and potential impact or rippleness. The readiness category refers to the maturity of a technology from lab demonstration, that's 1, to mass production, that's 5. The novelty scores refer to how new the innovation is. 1 means small differentiation to existing technology, and 5 means the innovation fulfills a new function. Finally, the ripple scale is our opinion of a technology's potential for life-changing impact and how widely it can be applied elsewhere. How does this shape-shifting robot stack up? The mass production of robots made of this kind of microparticles won't be particularly challenging, as similar materials have been used in motors and generators in various industries such as automotive, aerospace, and renewable energy. The manufacturing technique of the material could be rather matured, although producing robots with it would be different. I would say the readiness of this robotic technology for the market is likely very high, above 4 perhaps. Similarly, the level of novelty is also very high. Not long ago, this kind of robot is still considered to belong into the realm of science fiction. So here again, it gets a 4. Finally, the ripples. It all depends on the application and unit cost. The only thing to limit its potential application would be the boundary of our imagination. On the other hand, the specific cost of each product will depend on the design and specification of the product, as well as the cost of the raw material and the efficiency of the production process, the productivity, I mean. For all these reasons, it is a 3. And that would push it beyond the threshold of our standards. Imagine having a widely commoditized alloy particles that can become any object when it's needed at any time of use, instantly reshaped, reused, and stored away without having to go through any sort of recycling facility. What this could mean to our concept of reuse, reduce, and recycle. Well, let's take an example of someone repairing a car or whatever. All she has to carry around is one reshaping device to form all the tool needed to get the job done. On a more personal level, you never have to worry about losing a specific socket or a unique shaped screwdriver. What other use can you make of this technology? What impact would it bring to the industry that you are in? We look forward to your thoughts as usual. In the meantime, be careful next time a familiar looking person approaches you and tells you,
"Say, that's a nice bike."